There's a problem up on the board here. This one is for you to try. F of x is the square root of 4x minus 7. I'm asking you to first of all find f prime at 4. That's the derivative or the slope of the tangent line when x is 4. So that's going to be similar to what we did in the last video, but with a different function, obviously. Part B is new, but this is just an algebra problem. This is the slope of the tangent line. I'm asking you to find an equation for the tangent line. So go ahead, pause the video, try to work out those two problems, and then check back in and we'll work through them together. Whenever I'm finding a derivative by using the limit definition of the derivative, which is what we're doing now, because we haven't learned any shortcuts yet, I like to have a picture. So I want to draw a graph of this function. Now, I can see this is just going to be a square root function, but instead of starting at the origin, it's going to start when 4x minus 7 is equal to 0, which would be at 7/4, which is just a little bit to the right. So my function looks roughly like that. Okay. Now, I'm concerned with the point where x is 4. If x is 4, when I plug that in, I'm going to get 16 minus 7 is 9. Square root of 9 is 3. So the point 4, 3 is the point of tangency that I care about. I want to draw in another point that I'm just going to label x, comma, root 4x minus 7. And then I can draw in that secant line. And then I can say f prime at 4 is the slope of that tangent line. That's going to be the limit as x moves closer and closer to 4 of the slope of the secant line. Just rise over run. The rise would be root 4x minus 7 minus 3 over the run is x minus 4. And if we set this up right, I know top and bottom should both be going to 0. Clearly the bottom is, and we saw when we plugged in 4, we got 3. So the top is going to 3 minus 3. That's also 0. Okay. This time, we've got our indeterminate form of type 0 over 0, but we've got roots involved. So I'm going to try to just rationalize this by multiplying by 1 in the form of the conjugate, root 4x minus 7 plus 3 over itself. So remember, the conjugate is just going to be the same two terms, a root 4x minus 7 and a 3, but connected with the opposite sign. Okay, so let's see what that gives us. We're going to have the limit as x goes to 4. Now on top, when I FOIL this out, the first terms just become 4x minus 7. Outsides and insides are going to cancel because they'll be exact opposites, and then I get just minus a 9. On bottom, I'm going to remember to be strategically lazy and keep this in factored form. Because remember, I'm hoping that I'm going to be able to cancel this factor of x minus 4, so I don't want to make the bottom more complicated. I want to keep that piece separate. Okay. If I look here on top, this becomes then the limit as x goes to 4 of 4x minus 16 over x minus 4 times root 4x minus 7 plus 3. On top, I can factor out a 4, so that's the limit as x approaches 4 of 4 times x minus 4 over x minus 4 times root 4x minus 7 plus 3, and I can cancel those x minus 4s. Now, I didn't do a good job of saving myself enough space here, so I'm just going to jump over here. We've got the limit as x goes to 4 of 4 over root 4x minus 7 plus 3. This factor that I kept separate here is still there on the bottom, but now I can plug in 4 for x because it doesn't make the bottom 0. So this is just 4 over root. That's going to become 16 minus 7 is 9 plus 3. That's 3 plus 3 on the bottom, so we get 4/6 or 2/3. So that's our answer for the slope of this tangent line. I'll just remind you, as long as I still had x's in my expression, I was writing the word limit. I dropped the notation of writing limit at the time I plugged in 4 for x, so that I just had numbers. Okay, for part B, I want to find the equation of the line. Now, there's more than one way of doing this. I generally am going to use point slope form, because when I'm finding a tangent line, I'm almost always going to have a point. In this case, that's 4, 3. That's my point of tangency. And I'm going to have my slope, which was f prime of 4, which we just calculated is 2/3. Okay. Now, point slope form, if you learned it in an algebra class, some formula that's got x1s and y1s and things in it. And when I first learned it and had to memorize it, I hated it because it just was a complicated formula with subscripts in it. Okay. But what I can do is basically just say point slope form is just the definition of slope. I've got my 0.43. Here's my tangent line, is this line that we've drawn in here. I'm going to just draw an arbitrary point xy over here. Now I know that slope is rise over run, but I can rewrite that as a multiplication problem. Rise is equal to slope times run. And that's point slope form. All I'm going to do is I'm going to calculate the rise and the run using an arbitrary point xy and my specific point 43. So the rise would just be y minus 3. That's the difference in the y values. That's equal to the slope, which is 2/3, times the run, which would just be x minus 4. I'm totally fine if you stop here and you give me the equation in this form. That's a perfectly acceptable equation for a tangent line. If you prefer, you can solve it for y. So this would be y minus 3 equals 2/3 x minus 8/3. And then I could add over that 3, which would just be 9/3. So we get y equals 2/3 x plus 1/3. Either of these would be a perfectly acceptable form for an answer on a quiz or an exam.